Okay, we're going to look at how you can use GeoGebra to construct perpendiculars, and in particular perpendicular bisector of a segment, and then we're going to use GeoGebra to help us come up with a conjecture that then you can prove. So again, I started by going to www.geogebra.org, ending with .org. I get this home page. I click on Start GeoGebra. I click on Geometry to get my canvas. I'm going to start by making a line. So here on my third button from the left, I'll pick Line. Now, I don't have any points to select, but when I left click and drag and then release that left click, it will give me 2 points. So I can kind of do it all at once. I get my line and 2 points. Now I can make perpendiculars in several different ways here. When I click on the perpendicular line selection here, fourth button from the left, top menu item, it says to select a point and the perpendicular line. So for instance, I could select this point that's on the line and the line itself, and it will give me a perpendicular right through that point. So that's one option I have. If I had a point that was off the line somewhere, I'll just stick a point there, I could make a perpendicular by selecting this point that's off the line and this line, and it will give me a perpendicular. So sometimes that's a useful thing. The other construction that we did that took several steps was we wanted to have the perpendicular bisector of a segment. So just think about the segment between these 2 points here that we started with. If I wanted to construct the perpendicular that is exactly halfway between them, I can do that all in one step in GeoGebra. Okay, so let me hide a few things that are not really relevant here. So I'm going to go to this right button, Show Hide Object, and get rid of that line, and that point. Click on another tool to make them go away. Okay, so now we're back to just having 2 points, and I want the perpendicular bisector between those 2 points. So on my line, these special lines here, fourth button from the left, I go down to the third option for perpendicular bisector, and the gray box tells me to select 2 points or 1 segment. So I'm going to select these 2 points, and there, it has given me the perpendicular bisector between those 2 points. Okay, so all in one simple step. Now here's something that we can do with GeoGebra though, is we can investigate and look for properties, come up with a conjecture that then we might be able to prove. So for instance, in this example, now that I've got my perpendicular bisector, I'm going to put a point on that bisector. I'm going to go to my point menu and go to the second line where it says Point on Object. Select that one. It says to click inside an object or on its perimeter to make a point. Well, I want it to be on this line. So I'm going to make sure the line gets bold, stick a point on that line. Now when I use my Move tool, notice that I can slide it up and down that perpendicular bisector, but it's never going to go off the perpendicular bisector. I defined it to be a point on that perpendicular bisector. Now what I'm interested in is the distance between that point and each of these original endpoints. Okay, so I'm going to construct segments. So go to the third button from the left, pick Segment, connect those 2 points, connect those 2 points, and then to measure how long each of those segments are. So 1, 2, 3, 4. Fifth button from the right, go down to Distance or Length, and I'm going to select this segment and this segment. Right now it tells me both of those segments are 9.2 centimeters. Now look at what happens when I move this point to another place on the perpendicular bisector. These distances are 11.75. They're both the same. And if I move it all the way down here so it lays right on the original line, well, of course, this is the perpendicular bisector, So 5.87, 5.87, that's actually less surprising. But what's more interesting is that when I get away from the original line, this distance on the left is still equal to the distance on the right. So it seems like we might have a conjecture here. Let's use a text box here and write a conjecture. I'm going to say, I think, conjecture, a point on the perpendicular bisector of a segment is equidistant from the endpoints of that segment. And I think I'll make it bold just to make it look more important. Okay, and I'm going to use my move thing to put it up here. Okay, so think about what we know here. We know that this segment here, we can even give it a name, right? Oh, no, don't do that. I only want the labels. Call this A, and this B, and this D. This segment AB was our original segment. Here, this is the perpendicular bisector. It would be nice to be able to name it. So let's get the intersection point right here. Point intersect. Right at the intersection. There. That is point, what is it? Point E. Okay, so DE is the perpendicular bisector. It's perpendicular and it bisects. Those are both important things to notice as given information. Okay, so knowing that given information, can you prove that these distances, AD and BD, are in fact always going to be equal? You should be able to prove that. So take a few minutes, write down what you know, and think about what theorems and facts we have available to us, and see if you can tell why this is in fact going to be a theorem, that a point on the perpendicular bisector of a segment is going to always be equidistant from the endpoints of that segment.